Everyone, greetings. My name is Melissa Arce, and I will be the webinar moderator for today's event. Welcome to the third Masterclass Series webinar of OMS eLearning Academy. Today's webinar topic is Economics of Butane Disposition, LPG versus gasoline blending. We have an overwhelming response of 100+ registrants from 20 countries, and welcome you all and hope that you all will have a very informational and interactive session today. Before we get started, I'd like to go over a few house rules. The webinar will be about 40 to 45 minutes long with 10 minutes for Q&A. You can enter your question in the chat box during the presentation at any time. It will be answered at the end of the presentation. The webinar will be recorded and available on the OMS eLearning Academy website. There will be 2 question polls at the end for your input. Please give us your candid feedback at the end via the redirected Google form. Today's webinar speakers are Dr. Suresh Agrawal, the founder and CEO of Offsite Management Systems, LLC, and Academy Director of OMS eLearning Academy. Our second speaker is Mr. Tom Edwards, the president of Technics Incorporation. Offsite Management Systems, LLC was founded in 1998 in Houston, Texas. It is chartered to provide consulting and refineries automation projects executions worldwide. OMS eLearning Academy was founded in 2018 to provide continuing education to professionals working in the downstream refining industry and related businesses via the eLearning platform. The Academy has 200+ courses that can be taken online at any time, anywhere, and on any device. Technics Incorporation was founded in 1995 and served the oil and gas and other industries worldwide with complete turnkey systems for various demanding applications. You will learn 3 ideas of butane blending in this webinar: concept, economics, and application. With this, let me turn over our first speaker, Dr. Agrawal, to start the webinar. I'll be back at the end of the presentation. Thank you.
Thank you, Melissa, and greetings, everybody. So the first part of this webinar is to talk about concept, economics, and the second part will talk about commercial application by Tom Edwards. In concept, we'll talk about what is butane blending, gasoline properties, and seasonal RVP specs. Second sub-part of the webinar will be what's the economics of butane blending, what are the disposition options, blend models, and tangible benefits. And third part, Mr. Tom Edwards will give an illustrative example of a commercial blender, analyzers, and control system. So what is butane blending? Butane is added in an inline gasoline blending systems, and 8 to 10 components is to control the octane and Reid vapor pressure, the RVP. The amount of butane is small, 1 to 2% gasoline, and the gasoline RVP spec is low in summer. However, when the RVP specs are higher in winter, butane is added in gasoline pool to minimize RVP giveaway, as it can ramp up the RVP value in the gasoline pool. Butane blending refers to the addition of butane in the gasoline pool. Let's look at the gasoline specs. A refinery grade rates its gasoline based on the octane rating due to its required fuel quality for different vehicle models. The octane rating does not depend on season or regions. On the other hand, RVP changes is a specification based on the season or area to avoid vapor lock in summer and provide enough fuel volatility in need for the automobiles to operate correctly. Now, some of this concept presented in this webinar are mostly suited to USA, but the principles are same and it can be applied anywhere in the world. So the RVP spec changes and also T10 to T90 distillation points are also seasonal specs because they affect the volatility of the fuel. Other specs are dictated by pollution control measures. So we'll discuss two component blending in the webinar, namely blending butane in 87 gasoline to minimize RVP giveaway. Since butane also has high octane, we will also minimize the octane giveaway in the fuel final blend to further maximize the benefits. Butane has a high octane, if you look at this chart, in 93, and it can use its octane value in the final blend with butane. In terms of mechanics of blending, we'll discuss three models, linear and nonlinear blend models for the blending of butane and gasoline. So based on the USA scenario, refineries in USA have three seasonal and regional phases of gasoline production corresponding to RVP spec given by EPA. Ramping down period start from January 15 to May 1st is to reduce RVP content from 14 psi to regional spec of 7, 7.8 or 9 psi. This is called ramping down phase. Stable operation summer is from May 1st to September 15th, with regional RVP spec was 7, 7.8 or 9. Winter season starts September 15 to January 15, has potential to maximize RVP content and gain benefits from minimizing RVP giveaway by butane blending. This is ramping up phase. Have you ever wondered why gasoline is so expensive in summer? It's not necessarily because the demand is higher, but the cost of production is also higher. Refiners must use expensive components to meet octane value, and the RVP spec is low, and they can meet that just by RVP values of the component. As winter comes, refiners start using more butane to take advantage of higher RVP specs, and butane can meet the requirement at much lower cost. Hence, the price of gasoline comes down in the winter months, and also demand is lower in winter as people do not travel on vacation by road. Now let's look at the economics of the butane blending. The butane has two disposition routes, either an LPG, which has 69 to 70% butane, or gasoline to meet its higher RVP spec. The price differential between butane and LPG is $1 per gallon. Now, this economics may change based on the current season or the country, but the principle is the same. So, whereas if butane is added to the gasoline, it gives a price spread of 2.49 per gallon, a profit of 250% over its LPG value. Refiners and traders cannot ignore this substantial economic incentive of butane blending. The same benefit will depend upon gasoline, LPG, and butane prices and vary from season or country, but the basic economic principle is the same. Let's discuss the supply chain of butane. Large refineries produce butane from natural gas processing, from crude processing, or natural gas processing from gas field. Small refineries import butane from external sources. Butane is then stored in refrigerated tanks at the refinery or temporarily in trucks or rail cars. Gasoline comes from a local refinery storage tank or pipeline from remote refineries. Butane then can be used in a small quantity or small quality in inline gasoline blending, or large amount is post-gasoline blends using butane blenders. I discussed before, butane blending is a two-component blend, while inline blending is a multi-component blending. Blended products are dispatched to end user either by tanks, pipelines, rail cars, trucks, ships, or barges. Butane is also blended directly into pipelines, ships, and trucks at terminals. Butane blending is simpler than gasoline blending. Gasoline blending must use many models for different qualities and must optimize the blend composition. Butane blending, on the other hand, is a two-component blending system and is deterministic. Butane and gasoline composition unique for a given blend RVP and does not require an optimizer. RVP has three models, linear and nonlinear. Texaco mode does not have its customizable parameters, and it just adjusts RVP value of butane in the blend. The index method has a parameter X, with a generic value of 1.25, but must be customized by regression in the gasoline blending system. Both Texaco and index method can include a bias term from feedback. This slide shows the two-component butane blender and shows how we can solve its composition deterministically. Texaco model modifies the practical RVP value of butane in the blend. The index method changes RVP values of butane, gasoline, and blend to blend them linearly. The composition of butane and gasoline in the blend can be solved very simple using Excel. My company had developed an Excel-based calculator to estimate the benefit of butane blending for September the 15th through May the 1st, assuming a daily batch of 100 kb of blend. I used the Texaco model to give the most conservative estimate, but calculator used all three models for comparison purpose. It shows that butane blending can generate additional revenue of $236 million for 6 months of winter, or $1.32 million per batch of 100 kb gasoline. Butane is used as much as 14% to ramp up RVP to 13.5 psi. You can use this calculator to input the price of butane and gasoline for different grades at different locations in the world. So what we have learned that butane blending is simpler than gasoline blending in terms of number of components and blend models. It presents a vast economic opportunity to realize $237 million in just 6 months. Now I'll present Mr. Tom Edwards to discuss a commercial butane blending system.
Thank you, Suresh, and hello, everybody. We are now going to get into the mechanisms of butane blending. We're going to first discuss the system considerations, the overall strategic kind of use of it, and then we'll go over a commercial blender project that we did. Talk further about the important analysis system and also the important control system. So the first step is the storage of the butane. There are various methods of storage, and your choice is really going to be a matter of circumstance and not actually your choice, right? So if you don't have a dock, you're not going to be able to get it from a ship. So, but if your plant has existing bullets or steers for storage, then you're good. Otherwise, we're going to have to decide whether to have a permanent storage facility installed, or if we're going to use a temporary method, like rail cars or trucks or ships. So the permanent storage method is better because we don't have any disruptions from whether the truck arrives late or during a changeover from one truck to another. Also, while the temporary storage method is going to be less costly, if that truck or rail car is going to sit at your facility for a month, so that might not be thought of as a temporary storage. Once we have our storage figured out, we're going to have to transfer that butane to the process. That transfer is straightforward, right? We're just going to use pumps. The only important part is that there's going to be a gaseous phase of that butane, and we can't really inject that in the process. So as we set up the transfer system, we're going to have to take that into consideration. Now we're going to need to meter this butane into our process, and note that the amount of butane we're putting in is going to vary greatly over the year. The amount of gasoline that we're blending into may also increase and decrease. So we're going to have to take care with the mechanism we use to do that, because we're going to see like 100-to-1 turn down ratios. The gasoline meter is not an important aspect of that, but the butane meter is. So we're going to use Coriolis meters because they can ignore the gaseous phase. They can also detect the gaseous phase. So there's really no reason to not use a Coriolis meter. The RVP analyzer is almost always justified because you can target a final RVP very close. It is not a necessity because, as Suresh mentioned, there are algorithms where you can determine the amount of butane that you need to put into that stream. The trouble is you're not going to be able to target plus or minus 0.1 psi on your RVP because if you go over, it's a big problem. So our systems use these RVP analyzers. They require a 7-minute period to retrieve the results. And we always incorporate two. One, the method that is used is a triple expansion method. So these systems have piston within them, and that's susceptible to failure. So with using two analyzers, we can always have a backup in case one fails and needs to be repaired. Further, by using two, if they're both operational, we can stagger them so we can get results in 3.5 minutes rather than 7. Okay, so now that we've done that, where are we going to blend this gasoline? The pipeline can do it. We can intercept as the gasoline comes off the pipeline and travels to the tank. We can do it after the tank and before the trucks or ships, or we can do it within the tank itself. So from the very beginning, the method was to roll up a butane truck and start feeding that butane into the storage tank itself. But the risk is fairly high that that butane will not properly mix, rise to the top, turn to vapor, and then have some consequences to your floating route. So we don't recommend that. We recommend that this blending occur into a flowing stream in line. All right, so you're staring at a inline butane blender that we installed. It is a 12-inch gasoline pipeline feeding multiple truck racks. So this is a start and stop process. And because there are multiple trucks, the flow rate of the gasoline varies widely. So we are definitely going to need here a 100-to-1 turn down ratio on our butane. We'll have 2 feeds in parallel with Coriolis meters, one high, one low. There's an important aspect of this in that we need to have sufficient back pressure on that gasoline so that when we inject the butane, it doesn't immediately go to its gaseous phase. So that happens around 50 psi or so. This particular unit has a mechanical back pressure regulator, but it's just as easy to use a butterfly valve with flow control or back pressure control. It has 2 analyzers. It receives butane directly from a truck, so there is no permanent storage facility. And interestingly enough, this particular unit is in a tropical location. So it's not just the northern regions that can benefit from this. The RVP analyzers. So this is a typical arrangement. You can see in the center to the right, dual setup for the analyzers themselves, the control cabinet to the left, and then beneath you will see fast loop pumps, 3 of them. One is measuring the butane, one is measuring the raw gasoline, and one is measuring the blend. These units will switch between each of them as necessary. And so there are various manufacturers, right? Straubner makes them, Aerolytics, PAC, ABB. They all have these analyzers. They all function exactly the same. These analyzers to be require a nitrogen purge and climate control on them. both heating and cooling. And because they have raw gasoline or butane within the cabinet, a nitrogen purge rather than air purge is required. They also need to be calibrated at least once a week, and that's done can be done automatically. So let's take a better look into the blending process. And here you're looking at the dashboard of the control system. You'll see that so the gasoline is a simple wild stream. It's allowed to free flow. We just measure it. We measure its RVP prior to blending, so we know if we can put any in or about how much we should go. We should, right? So we don't want to overcharge at the beginning. We also are going to monitor the pressure of that gasoline because we don't want to throw butane into an atmospheric pressure line and have it turn to gas right away. So the control system prevents that automatically. So when we start putting in the butane, then we've measured the RVP of the gasoline. We're going to use an algorithm inside, like Suresh discussed, and start putting in butane, targeting a point lower than the maximum allowable. Once that occurs, 7 minutes later, we get to read the results of that. And with that feedback, then we begin adjusting more butane in. And this unit, we're going to record the volumes used all the time.
Absolutely. So thank you all so much to our speakers today. Thank you for joining Dr. Agrawal and Mr. Tom Edwards for a very informative webinar. I now invite Dr. Agrawal to back to wrap up the webinar.
So what we have learned today, we have learned the concept of butane blending with respect to significance for the gasoline properties. Then we also showed a way or discussed a way to how to estimate the tangible benefits due to seasonal and regional RVP specs. And we have developed a calculator for that. Now, again, this concept, even though we discussed with the USA scenario, but it can be applicable to any country or any region in the world. Then finally, we also discussed a commercial butane blending, and Mr. Tom Edwards might be able to discuss that. This is a calculator that you will be receiving after a review and giving a wrap up. Our next webinar will be the benchmark or refinery fuel blending system on January 12th. Please sign up for that. Registration will start in a couple of days. Our next webinar is how to benchmark a fuel blending system as it affects the bottom line. Now we have just two questions, poll question to ask. Melissa, can you trigger that?
Absolutely. Before we get to the poll question, there is one question in chat. The question is this butane blending economics valid under all scenarios? And what factors other than economics affect the butane disposition to the LPG versus gasoline?
Well, even though the concept is valid for USA because there is a wide variation in temperature from north to southern region and also EPA specs. But let's talk about a country like India. I was looking at some internet search, and surprisingly, the consumption of LPG increased in 2020 more than 2019. And the reason were because of the pandemic COVID. And people were staying more to cook rather than driving. So economy really depends upon the region and country. And the calculator can really tell you is it beneficial or not.
All right. Thank you so much for your response. If there are any more questions, please go ahead and place them in chat. And I will go ahead and now display the poll questions. Please do take a moment to respond to those two questions that have appeared on your screen. And again, if you do have any questions, please go ahead and place them in the chat box, and I'll be happy to ask those questions. All right, it does look like there are no more questions. I'll go ahead and close in another 30 seconds. If you have not had a chance to respond to the poll question, please go ahead and do so now. Looks like a question just came into chat. So before I close the poll, I'll go ahead and ask the question and give you more time to respond to the poll questions. The question is do you know if losses using a post-blend butane blender could increase compare with online gasoline blender? And then how long could be the temporary storage that you had mentioned during?
Well, the temporary storage is all about, is all determined by your, HSE department or the local authorities. So it's difficult to determine that. Most people just simply do not have an issue with it. So you could leave a truck there for a month and it would still be considered that. As far as losses, I guess I don't understand the question completely.
All right. Well, at this time, we do not have any more questions. The polling question has been completed. That does conclude today's webinar. Thank you all so much for joining us today. If you were to have any questions, please feel free to send us an email and we'll be happy to address them. Thank you so much and have a wonderful day.